Okay, this is going to be a demonstration of SPSS for homework number 2. So I'm going to walk you through each of the steps that I do. The output you'll find on the PowerPoint that accompanies this demonstration, but this will walk you through how to set up the SPSS to run your analysis. So the first thing that we're going to do is we're going to set up so we can run the analysis to look at the assumptions. What we want to do is we want to go to Analyze. From Analyze, we want to choose Regression. From Regression, we're going to choose Linear. We've been here before. Okay, so in the Linear Regression, we're going to put our album sales for our dependent. We're going to put our number of plays on the radio for our independent, and we're going to put our band image for our independent. We're wanting to know if number of plays on the radio the week before the album comes out and the band image during that week will impact album sales. So we're going to take statistics. We click on the statistics and we get this, this window comes up. We want to make sure our estimates is checked, our model fit, our descriptives, our collinearity diagnosis, and our Durbin-Watson. We want all of those to be checked, and we're going to hit continue. Then next we're going to go to plots, and we're going to hit plots. And under plots we want the Z residuals and we want the Z predicted. We want Z residuals on Y, Z predicted on X. We want a histogram and we want a normal probability plot. This is going to give us the visuals of our residuals where we can check some of our assumptions. We're going to hit continue. We're going to go to save, and under save, linear regression save, we're going to hit standardized residuals. Covariance matrix is automatically clicked at the bottom, just keep it there. So this is your standardized residuals, and we're going to hit continue. We're not going to do anything under options. We're going to leave it the same. So now we have the basics that we can do in order to check our assumptions that we need to check for multiple regression. And there are basically 7 assumptions that we have to check our data for to make sure it's going to meet the assumptions. So we're going to hit OK. And when we hit OK, we're going to get lots of output. We've got our descriptive statistics, we have our correlations, we actually have our model summary, our ANOVA, our coefficients. We have everything we need right here at this point in time. The first thing we want to look at is actually going to be our, let me find it here. It's going to be our residual statistics. We're going to look at our residual statistics so that we can check for outliers. Now again, we can actually run descriptives and those frequencies, and we can visually look to see. You can visually look at your data. Do you have anything that really is an outlier? But just because it looks like it doesn't necessarily mean it may be an outlier in terms of impacting your residuals. So we look at this right here, this residual statistics. We want to look at standardized residual here at the bottom. We have a negative 2.927, we have a positive 2.599. There's 2 different ways to interpret this depending upon your statistical background. Some say if this is between -2 and +2, then you're okay, and they go with that, saying that that has to do with 2 standard deviations. But in reality, the best idea is a negative 3.29 and a positive 3.29. If your minimum and your maximum falls between that, then that means your minimum and maximum are going to be within that normal curve, and you're not going to have outliers. If you do have, if these 2 numbers right here fall outside of the 3.29 and negative 3.29, then you're going to actually have to look for your outliers and potentially remove it or convert it, whatever you decide to do for that. But you use residual statistics to do this. On the PowerPoint, I've put how you would write up this particular table. The next thing that we're going to look at is we're actually going to look for collinearity. And when we look for collinearity, we're going to look at our collinearity diagnostics table, which is right here. Excuse me. And hang on. Go back to your coefficients. I'm sorry. Here, this is your diagnostics table, but you don't have to worry about this. The one thing that you want to look at here is that these columns add up to 1.0. So this right here is 1.0. This is 1.0. This is 1.0. If on these right here you have anything that's going to add up to above 1 and be over 1, you have multicollinearity problems. But you can quickly check for that right here. So you look at your coefficients and you look at your number of plays on the radio, the band image. If your tolerance is less than 0.1 and your VIF is not greater than 10, is less than 10, then you're good. You've met the assumption. So right here, our VIF is 1.03. Our tolerance is 0.967. So we're under the 0.1 and we're under the 10 here. And everything here adds up to a 1. So we do not have multicollinearity. Our data has met the assumption that multicollinearity is not a concern. Again, I've provided a write-up on the PowerPoint for this table, the coefficients table. Next, we're going to check for independent errors. In independent errors, we're going to look at our model summary. Let me find we've got our model summary right here, and we're interested in this Durbin-Watson. The Durbin-Watson lets us know if we have independence of our errors. We want this number as close to 2 as possible. It's going to range from 0 to 4, but as close as it is to 2, that means you do not have a problem. We are okay here. We have a 1.8, so we do not have a problem with the errors, with our errors not being independent. If you have a number here that is going to be less than 1 or is going to be over 3, that could be considered significantly different from 2, and so you might not meet the assumption. Our data has met the assumption, and again, I've provided an example for the write-up in the data for this particular table. Now we're going to look for random normally distributed errors, homoscedasticity, and linearity. These are all done with visuals through the plots, and so there's a little bit of art to this part. But first of all, let's find our histogram. And on our histogram here, visually, we can see we actually have a really nice normal curve. So we don't have anything that's too skewed one way or the other right here. So just looking at our regression standardized residual, we're going to say that our data has met the assumption of being normally distributed errors, of having normally distributed errors. And then we're going to scroll down here and we're going to look at our p-plot. And our p-plot essentially tells us the same thing as our histogram. It's just the two are reinforcing each other. And you can see all of our dots, all of our cases are exactly on our line, with the exception of a little bit right here. But everything's pretty much on the line. Therefore, we are good to go. If you have your cases and they're not on the line, they're scattered around the line, then you could have some problems with independent errors. Right here, ours are good. We're all on the line, so we don't feel like we have any problems with that. It shows that we have approximately normally distributed errors based on these two visuals, based on the histogram and based on the p-plot. Again, I've provided write-ups for you in the PowerPoint. Then we're going to actually come to the scatter plot, and it tells us if our data has met the assumption of homoscedasticity and linearity. And again, this is kind of an art here, but basically what you want, and I've provided this on the PowerPoint, I've added lines here, you want this to be a shotgun effect. So you want to be fewer here and more at the end. So you're going to want lines that are going to come out like this. If you have a curve, if you have a circle, if you have something that's not like a scatter, and it's a shotgun blast, think about that. It starts smaller here and it goes out here, then you're going to have some problems. And again, this is checking for homoscedasticity and it's checking for linearity. And because our other stuff is pretty much on target, this one's on target too. And the picture that I put on the PowerPoint, I've imposed the lines right here so you can get a more of a visual of how this scatters out. So the next thing that we're going to do is we have to do just a little bit more of analysis here. So to get the last thing, so what we're going to do, I'm going to click off what we have. I've already used the tables in here that we need to use to assess for some of the assumptions. So we're going to click this off. And then I'm going to go back and I'm going to go to Analyze and I'm going to go to Descriptives and I'm going to stay with Descriptives right here. And over here I'm going to put my variables: album sales, number of plays, band imaging. Okay. Then I'm going to click my options and then I'm going to make sure that I have my minimum, my maximum, my standard. I'm going to make sure I have my variance. This is the key right here. This is what we're checking for, is the variance. We want non-zero variance. And then we have the mean. So we're going to hit continue and then we're going to hit OK. And we get this table right here. And all you're looking at in this table right here is your variance right here. And so we can see that we have no zeros here. Everything is above zero, so we have met the assumption of non-zero variances. And we're going to write that up as far as number of plays on radio has a variance of 150.54, and we're going to write up band image has a variance of 1.9047. It got close to zero, but we're all above zero right here, so we're good. We've met the assumption of non-variance. And again, I've provided a write-up for you in this. Now that we've determined our data meets the assumptions that we need to meet for it to give us accurate running, we're going to run our multiple regression. So we're going to go back to our regression. We're going to go back to linear. If I could bring it up, we're going to go back to linear. We've already got everything in here, so really all we need to do is hit OK. And then when we hit OK right here, remember we're concerned with model summary, ANOVA, and our coefficients. We show that we have a significant regression equation right here, okay? We show that in our R squared that there is 0.407, or about 41% of the variance in our album sales predicted by band image, and the number of plays on the radio, okay? So then we look at our coefficients. And I've provided the equation for the coefficients and the prediction equation on the PowerPoint and in my write-up. But basically for the constant is for 4.3, okay? So for 4.3 album sales, we know that 3.67 and 12.98 units contribute to one album sale. So to increase an album sale, or to get an album sale, we need to have an increase of the 3.67 in the number of radio plays, and we need to have a band image increase of 12.987. And looking at this right here, we can actually determine that our band image is going to contribute more to our increase in our album sales. It's a larger number. So the higher the band image, the more album sales we're going to potentially get. But those are the ones that you're concerned with. We've gone over that before. The model summary, the ANOVA, and the coefficients is what we're concerned with when we're running multiple regression. I'm going to refer you back to the PowerPoint and to the example I provided in a PDF document of a write-up for number 3 and 4. It's an example. Sometimes things vary just a little bit, but this would be more or less how I would present the information if I were writing it up. So hopefully this helps. I'm so sorry we couldn't do this in a live class last night, but if we need to do it in live class again, I'll be more than happy to do that.